Okay, let's do some more of these 2.1 problems. I think this is where I wanted to start. Let's check. Yep. So this is number 15. And by the way, I'm pulling these problems from your textbook. So I went to your online, like if you come here, chapter contents. It requires that you download a CDF player, which just is some sort of player. But I get it from there, and then I come in. So if you have a hard copy of your book, this is what it looks like too. But I'm just picking some of the questions from here that correlate to your homework. So that's where I'm pulling these questions from. So this is number 15. It says, consider the position function S of t equals negative 16t squared plus 128t. Complete the following table with average velocities. Then make a conjecture about the value of the instantaneous velocity. So here's one way that you can manipulate this problem and do this problem, make it a little bit easier, letting your calculator do the bulk of the work for you. So here's the function. So I'm going to come in here, I'm going to type in my function, clear this out, clear out this stuff, who was doing stuff, alright, negative 16x squared plus 128x. Now, what I'm going to do is I'm going to go to my window button. Not to my window, I'm sorry. I'm going to go to my second table button and change it from automatic to ask. And so what this does, let me see. No, I don't want to cancel that. Sorry. I want to make it to where this doesn't blink on there, so I have to do this weird little thing where I go blinky, 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 stop. Didn't get it. Aha, got it. I'll try to do that more smoothly next time. But what it does by ask here is now when I go into my table, notice I'm not even looking at the graph, but when I go straight into my table, it leaves it blank. And so I can figure out what these values are. So just kind of looking ahead here, I need 1, 2, 1.5, 1.1, 1.01, 1.001. So 2, 1.5, 1.1, 1.01, and then 1.001. Oops, I think I did too many there. Alright, so now what I can do is I can use these values to figure out my average velocity. So for example, for the average velocity from 1 to 2, the average velocity, if I look at my table, would be 192 minus 112 divided by 2 minus 1. So I can quit out of here. So 192 minus 112 and then divided by 2 minus 1, which is 1. So this one's going to be 80. And then I could do the same thing for the interval 1 to 1.5. So 1.5 was at 156, so that would be 156 minus 112 divided by 1.5 minus 1. By the way, guys, over here. So here I know the denominator is going to be 0.5. So I'm going to take the 156 minus the 112. I just don't feel like doing parentheses and all that, so that's why I'm doing it this way. But then divide by 0.5, I get 88. So 88. And now I can just continue doing this. So for 1 to 1.1, that would be 121.44 minus 112 over 1.1 minus 1. So I know that this is 0.1 down here. And so now 121, 0.44 minus 112. And then if I divide by 0.1, I get 94.4. So 94.4. Now, I could keep doing this. I could also have done the following. The other option would be to, and this is actually one way that I do it. Once I notice, again, I'm going to come back to my table, that it's 112 and 1, meaning each time I do this process for average velocity, it's always going to be the function at the number minus 112 and then the number minus 1, right? It's always going to look like that in each one of these intervals because they each start with the number 1. And so I could, if I want to be more exact, I could have done that technique where I do the vars, y variables, inner, and I could say, hey, evaluate this at 1.1, then do, minus 112. Oh my gosh. My hand and then divide it by 1.01 minus 1. So 95.84. So I could definitely do that as another option as well. So let's do this, 95.84. If you have, and let me make sure I'm in the right calculator mode. Some of you have the newer 84s. If you have the newer 84s, this is kind of nice because you can actually do alpha, y equals, and inner, and that'll give you a fraction. So you could just come in here, do this one time, and then just go in and change your numbers as needed. Oops. Close that parenthesis. Minus, we already know that's 112. And then divided by 1.001 minus 1. So 95.984. And so it looks like this is approaching 96. That looks like that would be its instantaneous velocity. Feels about right to me. So that's how you could do number 15. So a lot of these, it's more about the calculator tricks. Otherwise, it could take like a year and a half to do, by hand especially. The next one's a little weird because it's got the trig function. So the first thing is you need to be in radian mode. So we've got 3 sine of t. So I'm going to come in here and type in 3. Oop, before I do that, let me hit my mode button. I'm in radian mode. I don't care if that's working out. Alright, so 3 sine of x. Now, again, notice here we have pi over 2, comma pi, and then pi over 2 plus 0.01, pi over 2 plus 0.001. So, if you notice on that first one, the average velocity will be my function, my y value. Really, the function up there is in terms of s, but let's just be silly here. Y of pi minus y of pi over 2, and then I'm going to be subtracting. And I'm going to keep doing this for each one of these. And here's something I want you to notice. So on the next one, it would be y of, so I do the second number, pi over 2 plus 0.01 minus y of pi over 2 divided by pi over 2 plus not 01. That's what I get for doing this while I'm tired. 0.01, 0.1 minus pi over 2. So notice what's going to happen here. In this denominator, it's going to be 0.1. This denominator is going to be pi over 2. But if I keep going here, so if I were to do another one here, this one would be 0.01, 0.01. So that's something that's going to be handy to kind of notice. So I could go to my table. I already have it set up to do automatic. I could just hit delete, 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 delete here. And if I do pi divided by 2, it spits out 3. And if I do pi, it spits out 0. So what that means so far is up here, this would be 3, no, a lie. Yes, it'd be 0 minus 3 on the top. So, copy the top, dot flip the bottom. So negative 6 over pi, and I think it says to round probably. So I'm going to round it. So I'm going to kind of take this part off and just do that in a calculator. So negative 3 divided by pi halves. So I get negative 1.9099. Then I'm going to do the same thing again. I'm going to go back into my table. And this time I need to do pi divided by 2 plus 0.1. So I get 2.985. So 2.985 minus 3. Now, come back over here. 2.985 minus 3. And then I'm going to divide it by 0.1, which is going to move that decimal over. So negative 0.15. All right, now I would just continue this process. There was also the other option I had for doing this, and I was going to show you guys that again. I just want to make sure this was problem number, I believe, 20. Okay, yeah. So, the other option would be to do this. In this particular segment here, what you could do is you could do your, I'm going to do a parenthesis here. I'm going to do my vars, y vars, and I'm going to say x here, and then minus, and when we did pi over 3, it was 3, and then divide by, and then another set of parentheses, x minus 3. So, let me change this mode so that we can see everything that I typed in. Okay. So, if you want to kind of do this, and this is probably the quickest way to type in these two equations. And then notice all I want on these intervals, and I'm going to come and I'm going to make my life a little bit easy by doing this. So, the fact that I have 3 and 3 there is incorrect. It should be, I'm glad I caught that. It should be x minus pi over 2 on the bottom. Sorry for all the clicking. Okay. All right. what I was going to say is 3 and pi over 2, it's because of this, right? And because of the fact that y at pi over 2 equals 3 times sine of pi over 2. And at pi over 2, sine is equal to 1. And so we get a 3 from that. So that's why those always stay the same. So if I want to know my average velocity here, I would do y sub 2 at pi. This one would be y sub 2 at pi over 2 plus 0.1. This would be y sub 2 pi over 2 plus 0.01. Y sub 2 0.001. Y sub 2 pi over 2 plus 0.0001. The one advantage is with this is that it's gonna like give you the longest form of the decimal, so you can make sure the rounding is good. Also notice this, once I back out of this and hit quit, I'm gonna go vars to y vars, which is variables to y variables, function, but this time I'm gonna select the second one, and the first one I'm gonna do is at pi. Helps to type it in right. So I got that one. Now I'm going to do second enter to bring it back up, but now I'm going to do divide by 2 plus 0.1. And then second enter, just come back in here, add another 0 in there. And then I just have to keep going like that. So I just have 2 more to do. So that probably is the quickest way to do it. So second enter, 2, and then second enter. Now, one thing about this last little bit of business here is this e negative 4. That means to take this decimal place right here and move it 1, 2, 3, 4 spaces to the left. So it'd be negative 0.00015. And in fact, this one is the same thing if I round it. That'd be 0.0015. This would be negative 0.0150. This would be negative 0.1500 if I'm rounding to 4 decimal places. And this would be negative 1.9. This 8. That 5 rounds, so 0.99. And actually, be more precise here, that stuff, so it would be negative 1499. But over here, this 9 rounds out to, yeah. So that's how my rounding would go on that one. And I think it also says to make a conjecture. I think that instantaneous velocity of that looks like it's going to 0. Because those values are getting smaller and smaller and smaller. The last question here, the impact speed question, says that a rock is dropped off a cliff. Sounds like fun. And the distance is given by the function s of t equals 16t squared. And assume the distance from the top of the cliff. So here's the cliff. And here's the rock. This is 96 feet. When will it strike the water? Well, S of t is the height of the rock. So all we have to do for part A is set up this equation right here. So to set up this equation, I would first divide 96 by 16. And I would get 6. So 96 divided by 16 is 6. And then technically I'd do plus minus square root, but it can't be the negative one. So time equals the square root of 6 seconds. That's the exact time. Then it says to make a table of average velocities. And so what you can do there is you can make a table of yourself getting really, really close. And so you would just set that up and do like we did on the other tables. And I think in my math lab it actually gives you a set of tables to use, which makes that handy. Here, if I didn't, I could look at interval and then average velocity. Maybe I want to know, what if I'm 1/10 away? So what if I'm in this interval? And then maybe do one where I'm even closer, 0.01, comma square root of 6. Maybe another one, square root of 6 minus 0.001, and then the square root of 6. And so I would play the same game that we did before. So that would be 16x squared. And then when I come in here, oops, delete. When I punch in the square root of 6, I get 96. When I punch in the square root of 6, close it, minus 0.1. So I would subtract those values and divide by 0.1. And I would slowly do that and get closer and closer and closer. So eventually, in my table, I might have something like this. Square root of 6 minus 0.0001. Let's do another one. Let's do 0.1. And so I would get 95.992, and then I would divide it by, I would subtract that from 96 and divide. So just like the other ones. And so if I were to do all that arithmetic in the calculator, I don't know. Oh, I didn't subtract, that's why. Anyways, if you notice here, it's going to look about 78.3 feet per second would be the average velocity, something like that. But it works like the other ones. And so that should help you with 2.1, all of those problems. And if you have any specific 2.1 questions, let me know.